I'm assuming you guys are more comfortable in degrees. Then 1 minus 2 times the sine of 30 gives you, what is it? 0. No. 1 minus 2 times the sine of 45 gives you, let's round to the nearest, negative 0.4. We'll just do the nearest tenth. Because we're going to have to plot these, so there's no sense in overdoing it. Nearest tenth is good enough. 1 minus 2 times the sine of 60, negative 0.7. And 1 minus 2 times the sine of 90 brings you to negative 1. So we're going to stop there. Even though we have a full circle to go, we just did our first quadrant worth of angles. So a 0-degree angle, which is this terminal ray, has a radius of 1. So there's a point there. A 30-degree angle, which would be, I hate how this is. I'm just going to pretend like that's 30, that's 45, and that's 60. Even though that's probably not right. I just don't. Oh, maybe it is. Oh, that is right. Because they're counting by 15s. 15, 30, 45, 60. Oh, no, it's not. Oh, yeah, 75, 90. So a 30-degree angle has a radius of 0. So this is tricky. Because when you connect those, and this is something you don't really know yet, it's not going to be a straight line. So to see what happens, let's throw in there at a 15-degree angle just to see 1 minus 2 times the sine of 15 gives you 0.5. So if you were to do a 15-degree angle with a 0.5 radius, that would be right around there. When you connect points in all of this, it's going to be very loopy. So we started here, and so far we've gone through those 3. And that's kind of a curved loop back to the origin. Anytime your radius is 0, you're back to the origin, right? That's the only point on the entire graph with a radius of 0. Are we good with that? Okay, then 45 degrees, which would be here, is a negative 0.4. So that puts us backwards in this direction, and here's 1, so a negative 0.4 would be somewhere within the first circle. 60 degrees is obviously a first quadrant angle, but it's got a negative r. So if we come backwards on that ray, negative 0.6 is just going to be a little bit further out. Still within the first circle. And then the 90-degree angle goes with a negative 1, which puts you here. So if I kind of continue that looping and connect those 3, it does that. Are we good with that? Rock table's out here. Here. You big Wisconsin fan? I knew that we were friends after all of this. You still remember this? From Wisconsin? What part? All right. What's the next critical angle? You work? What town? Appleton, Wisconsin. Nobody believes that, JR. All right. What's the next important angle? 0, 30, 45, 60, 90. What's the... yes. Because it's a reference angle of 60, we're kind of on our way back down. The reference angle of 60 is 120, followed by a 120, 35, followed by a, and then the 180. So we're going to plug those in, 120, 135, 150, 180. I'll start with the 180. You guys start with the 120, and we'll do half the work. 120 gets paired with what? Negative or positive? Negative 0.7. 135 goes with negative 0.4. So I'm not surprised that 45 and 135 have the similar number. I don't necessarily know that they'll always be the same negative sign, but they both have the same reference angle of 45, so that makes sense. So now, to plot 120, which is here, and a negative 0.7, I have to go backwards, and I'm a little over halfway out towards the first circle. And then with 135 and a negative r, I also go into the opposite quadrant, and I'm a 0.4, so I'm a little less than halfway out to the first circle. And then here we get brought back to the origin. 150, no one really cares where 150 is. If you know you're at a radius of 0, you're at the origin. So that brings us back to, so do we see the loop that just happened? Yes. And then 180 is here with a radius of 1, brings us out there. We never connect with a flat line. Without plugging in something between 150 and 180, hopefully you can gather that that's just going to loop up and over. It's going to round to get from point to point, as opposed to, there, let me get rid of that glare. Everybody see that?
That's how yours looks?
Yours doesn't? So here are these 2 points that I just connected, the 150 and 180. You never connect with a flat line. You kind of continue your curvature and your loopiness to get from there to there. If you really wanted to plug in some random number between 150 and 180, you'd get something like a positive 0.2, so it would tell you that it's going into that quadrant at least a little bit. Are we good? Okay. Then when we keep moving around our circle, what's the next angles we're going to plug in?
210.
210 followed by, and 240. And then 270. So I'll work backwards, you work forwards. What do you get with 210 degrees? 2? Oh, good. 225? 2.4. And for 240, I got 2.7, and for 270, I got 3. So this is nice. Working with decimal radii is pretty tough because you're really cramming it in. But with 210, if you get 2, you're right here. So where we left off is going to curl around to that. Then 225 is 2.4. So that's a little less than halfway between the second circle and the third circle. 240 is 2.7, so that's a little over half. And then 270 brings you out to a third radii. So that loops to there. And then we're on to our last few angles. So what's gonna be the next 3 critical angles? 300, 315, and 330. And then that'll bring us back to the 360, which is gonna be the same as plugging in a 0 was. So I know we're a few short, but 300, 315, 330, and 360. 360 degrees is the same as plugging in 0 degrees, so that's definitely a 1. And then we just have to plug in those 3. So the 330 gave me a 2. What'd the 300 give you? 2.7, and the 315, 2.4. So finish up that graphing. 300 with a 2.7. 315 with a 2.4. And 330 with a 2. And continue your loop, and then it goes back to the original point. How was that? Well, it's all calculated, yeah. So to get any picture, you really have to plug it. You have to do one full rotation around the circle. Sometimes after your first rotation, it will be repetitive and it will kind of go over the same thing twice, which would really be half the work once you realize that. This one, the one that we happen to do, kind of looped around within itself, but some of them just kind of dimple and they don't fully loop ever back to the origin. They just kind of cave in a little bit and go back out. So you don't have to memorize these by any stretch of the imagination, but what causes the loop versus the dimple? If A is less than B, so all of these shapes, these limicons, have this structure: a constant, plus or minus, some coefficient in front of the sine or cosine. So in this particular case, our A number was smaller than our B number. Our A was 1 and our B was 2. So because our A was smaller than our B, we got the loop. If I ever flipped that around and I did something like R equals 2 minus 1 sine theta, I'd see more of that dimple. Does that make sense? You don't have to memorize that because that'll kind of happen on its own. But that's what happens. Good? We're not done. I just don't really love... All right, let's go to the cardioid. Why don't we do this so we can go fast? You guys do your first quadrant numbers, 0, 30, 45, 60, 90. Starting with Lydia and Maggie's rows, you guys do your second quadrant numbers, so your 120s through your 180s. My 3 girls on the far right do your third quadrant numbers, and I'll do the fourth quadrant numbers, and then we'll all share. You have to do the first quadrant. Second quadrant. And always round to the nearest tenth, just because being any more specific than that when you go to graph it isn't going to be helpful.
Do you eventually have to lose out?
No. All right, where are my first quadrant numbers at? Who's got them? Hold on, 4.5. Who's here? So 30 is 4.5? What would you have for 0, Ryan? Okay. Andrew? No, I wanted you to talk it out properly. Andrew, what'd you give for 45? What'd you get for 60? And for 90? Lydia, what'd you get for 120? Mike, 135. 150, Allie. And 180, Maya. 210. Are we in the next quadrant yet? You did it again? Well, I'm just going to spread the wealth here. Tori, what'd you get for 210? Val, 225? And 240, Maddie? And 270, Andrew? Yeah. And then my last three were 0.4, 0.9, 1.5, and 3. Okay, now we have to graph. Well, you have to graph all your points. So 0 degrees is a 3. 30 degrees, and I'm just going to put these out so These are different graphs than were on her notes yesterday, aren't they? Oh, no. Oh, no, they weren't. I didn't really put that together yesterday. All right, 34.5. 1, 2, 3, 4 and a half. What'd you say, Tanner?
Excellent time. I said 6.
Oh. So there's no negatives on here. So far through my first quadrant, and check yours, or first and second rather, check yours, but it's fairly symmetrical. It is symmetrical. It's perfectly symmetrical, and it does that. Yes? And then when I go through my third quadrant wraps up at 270, which means I loop back to the origin. And then 300.4. So hopefully after the progression of plotting all those, you can see why a loop doesn't actually happen. Like it curls back into the origin, but then it immediately bounces back out through the fourth quadrant. Because we don't have any negative values, so it's not like we then got to fourth quadrant angles with negative r's that would put us back into the second, so we never actually looped around. We just immediately came to a point and bounced back out. Does that make sense? We get it, right?
Yeah, that's good.
Okay.
Good book.
So, I really want to do one of these, but I don't want to make up a new note homework, so let me just look, or a new example. So, on your homework, I'm hoping there's one with an A bigger than B. Oh, there is. Okay, we're going to do number 4 together. you know what, you're gonna see a cosine one on this one. So, similar, not exact. Sometimes they're oriented, like, you see that one of the loops is oriented like left, right?
Yeah.
That could be because it's cosine, whereas the sine one that we actually get is kind of oriented moving up down. No. Right. So team effort again, we're going to start on the homework question number 4. Do the same quadrant we did the last time.
I'm supposed to be left of 2. You gave what?
Number 4. Because number 4 is a limit but it's got the A bigger than the B, so we'll be able to see why the one looped, but the other one will be just like a dimple. So number 4, do your assigned quadrant. That's what I'll be doing. One person taking and more people have it? Okay. How many do you want? Big. So why would I wait for that Yeah. But the mold is very strong together. Yeah. And then we can look at these are probably going to be 4 points. Okay. I got it. Oh well, maybe I'll just mark that for here. Who feels like they're mostly done, or nobody, because we didn't fill in the full table of values? All right, Alyssa, give me 0 through 90. 1. And quadrant 2, Allie? Mike? You didn't plug in a single number. Go ahead, Brock. Yep. 120. Okay. Okay. Lydia? 180. Start with 180. Right, and then I did 1.3 for 315, 1.1, and 1. So again with this, see how you have no negative values? So your first quadrant angles are positive radii. It's going to stay in the first quadrant. Second quadrant angle, positive radii, is going to stay in the second quadrant. Third quadrant angles, all positive, stays in the third quadrant. Fourth quadrant angles, all positive radii, it stays in the fourth quadrant. So you get something dimpled that never ever goes back to the origin. You don't have any radii that are 0, which means you never will touch the origin, so it's impossible to loop. Does that make sense? So that's your homework, those 4. We kind of got started on that one.